Okay, so we're going to keep talking about water and water pollution here in our second part of Chapter 18's lecture. The last lecture we were leaving off, or we left off with eutrophication and what happens there. Again, this is natural. It's just the speed. The speed is a problem. When you get this massive influx of nutrients, and let me point this out, big thing to remember, nitrogen and phosphate, N and P are the two key nutrients. So there's nitrogen, phosphate. When those run off into the aquatic system, it causes an algae bloom. Algae, yay, they like it. They get to grow. That's why we put that stuff on agricultural fields, is to make the plants grow. But then it gets into the water, algae blooms, but then when the algae dies, major decomposition happens, and that sucks out all the oxygen from the water. Go back to that BOD and the dissolved oxygen levels. That gets compromised during eutrophication when the algae dies off. So the algae die off, O2 levels decrease, or your DO levels decrease, and that's what causes your fish to suffocate and a collapse of the ecosystem. When it's in a contained environment like a pond, fish can't go anywhere. They die. If it's in the ocean, aquatic life leaves the area that has the algae bloom. That becomes problematic. Okay, so what we're seeing here in 2018 is the state of Florida is having some huge issues with this because of massive amounts of runoff, all of the nutrients washing in and causing algae blooms. Now there's different types. One type of algae bloom we're seeing is this type called a red tide. These are protists, dinoflagellates, they're photosynthesizers. They blow up, their population just explodes. And the problem is the dinoflagellates release toxins. They produce toxins as waste product. Well, you get this large concentration of these guys in a small area, especially a shallow area with slow-moving water, and that toxin builds up and it actually becomes deadly, dangerous. So the person swimming here, not real smart to be swimming in water that has red tide going on in it. So 2018, the state of Florida has got some major problems with this. It's actually becoming a major issue with the 2018 elections. Some of the people are voting for candidates based on their policy for water quality, not other issues, water quality, and are they going to clean up the water? Are they going to help protect Florida water? That's a major concern for a lot of voters in Florida right now in 2018 with that election there. All right, so other things get into the water that lead to problems. Inorganic pollutants, metals. So here's our major metals that we worry about: mercury, lead, cadmium, tin, nickel. Those are the highly toxic metals that get into water. They are persistent. They also bioaccumulate. So these are not POPs because they're not organic. These are inorganic, but they follow the same pattern. Persistent pollutants that biomagnify and accumulate up through the food chain. So here in Illinois, we have a fish advisory. So this is a hyperlink that'll take you guys out to Illinois Fish Advisory map, and it'll show you the places in Illinois where you shouldn't eat fish because of the accumulation of inorganic pollutants. Primarily mercury is the main one that we're looking at. Top level fish, long-lived fish, are the ones that accumulate this. So bass, oh, big 2.5, 3, 4 pound bass are fun to catch, but odds are they're going to have some mercury in their tissue because it's bioaccumulated into that fish. Catfish as well. Those are the two main fish that most of us in Illinois would come across. I mean, other fish like walleye, sauger, muskie, those guys have it because they're even higher on the food chain than bass and catfish. But most people, they're going to eat fish. If they're eating fish, they're probably eating bass, catfish, and bluegill. So 2 out of the 3, unfortunately, have problems with inorganic pollutants, primarily mercury in them, and it can become very toxic. So there's all sorts of other pollutants, and we have organic pollutants. We talked about the POPs, so that's something, I keep coming back to that stinking term. I'm going to keep grilling this into you guys. But POPs, persistent organic pollutants, those can pollute water because they just sit there and accumulate and accumulate. And then when we look at, well, where does it come from? Well, the two most important sources that these different pollutants come from, industrial and household disposal. So what is industry doing and what are we doing ourselves when we have cleaning agents and we use that? And I'm not saying we don't need these things, but we just want to think about how much are we using and how are we disposing of them. And then also runoff from things that are used on our fields, pesticides, herbicides, different chemicals from fields, roads, golf courses, etc. Think about how many people fertilize their lawn. And that fertilizer, what does it do? It sits, it may get absorbed, but if it doesn't, you get a heavy rain, it then runs off and it winds up in the aquatic system. So all these things contribute to problems with water quality. So here's just a table showing us the most common organic contaminants. Believe it or not, steroids are the number one. They had the highest level of detection in the samples. Steroids, non-prescription drugs, insect repellents, detergents, disinfectants, etc. You go through the whole list there. Those are things that are in water. Some of these are products we're taking. Our body doesn't break it down, so when we go to the bathroom, it winds up in the toilet. We flush, it goes to the waste treatment plant. It doesn't get broken down there, and then it gets discharged into the body of water that the treatment plant discharges into. So we'll talk about that in a later lecture, how these things basically flow through us, through the system, and wind up in the aquatic system. But there's lots of stuff out there that is causing some problems with our water quality. All right, so now let's take a look at some other sources of water pollution. And these are things you probably don't even think about really, but we've talked about sedimentation. That's a huge issue. And we often go, well, that's just dirt. Well, that changes the quality of the water, which impacts the health of the living organisms. That fits the basic definition of water pollution. So we're looking at dirt mostly from agricultural runoff. Thermal pollution. Heat. As weird as this may sound, power plants, when they produce power, they need to cool parts of the plant for the production of power. So they often build the plant right next to a body of water, and then they will pull the water in, run it through a cooling system, and then discharge the water to keep the plant from overheating. But the water getting discharged is warm. It's kind of like the radiator on your car in a cooling system in a vehicle. So the water being discharged comes out warm. And you say, well, what's the big deal? Well, warm water has less oxygen in it. So that changes the oxygen levels. That also changes the temperature of the ecosystem that it's dumping back into. That can impact the fish, the different invertebrates, the different producers, if there's a shift in the temperature. So it changes your actual aquatic system because you're heating a system that normally isn't heated. Think about global climate change. Temperature increases can lead to problems. So it seems like a small issue, but it does impact bodies of water because a lot of our power plants are located directly on a body of water. Think about CWLP in Springfield, sits on Lake Springfield. Acids go into water, creating problems. We talked about that in previous lecture when we were discussing mining issues and pollution coming out of different ways that we mine minerals and fossil fuels, things like that. And then another one that most of the time we don't even recognize or really think about, salt. Some areas this is far more prevalent than others, obviously. Road salt. So in the winter, Department of Transportation dumps tons and tons and tons of road salt on the roads to keep them from getting icy. Keep people safe. That's important. That's very important. But then when that stuff melts, it washes off the roads and it usually dumps right into a body of water. So now you're going from fresh water to water with salt in it. Think about what happens there to the organisms that are trying to live in fresh water, and they've just had tons of salt washed into the body of water, creating a slightly brackish or a body of water with a slight amount of salt in it. So that can have an impact on an ecosystem as well. Definitely changes water quality when you dump a lot of salt into it. All right, so we're seeing some significant challenges and some significant problems that come from us altering water quality. So there are good things on the horizon. There's some good news. Clean Water Act, established in 1972, was done to identify point sources of pollution and say, okay, bad. Let's put the big X. Bad, bad, bad. We know you're polluting. We need to fix this. What Clean Water Act was doing, again, identifying point sources, where is the pollution coming from, but also trying to identify what's called total maximum daily load, TMDLs. How much pollutant can be discharged per day? The reality is you can't say no pollution, zero. It's not going to happen. But can we find that threshold? What is that level of pollution, that threshold or level of pollution here, that is acceptable, that doesn't produce ecological consequences that are damaging, that doesn't pollute to a point where life can't be sustained? Where's your threshold? And let's set a line. So you cannot go over the threshold. You have to keep your pollutant discharge underneath the threshold, and you're fine. Keep doing your business as usual. But if you go over the threshold, now we have to get into remediation, fines, lawsuits, etc. So that is the direction Clean Water Act is trying to go, to protect the quality of water for all humans. It's not just for a specific group, it's for all of humans, because we're all connected to the same aquatic system, that hydrological cycle. So it's made some great progress, but we still have some problems out there. Non-point source. This is the bane in EPA's side, in water quality experts' sides, going, gosh, how do we identify these non-point sources? So back in '98, EPA shifted their tactics, and instead of measuring point sources, this pipe, that pipe, they went broader scale and said, let's look at the watershed. So remember that term. We talked about it. Make sure you're comfortable. Watershed, all of the land that drains into a particular body of water. And they're saying, let's look at bigger picture and focus on watershed levels. Because if company A is discharging a little pollution, company B is discharging a little, and they're all under the threshold, what happens when they all combine? Now, combined, are they above the threshold? That's a problem. So they're looking at the broader picture. But we still do have problems. I mean, nobody's going to say it's perfect and that it's fixed completely. We still have problems. The three top sources of pollution today, the three biggest ones that are creating the most problems for us, are sediment. Usually that's from runoff, right there. Excess nutrients leading to eutrophication. So there's our sediment, there's our nutrients, and then pathogens that are getting into water. So the goal here, the idea here is, we know the problems. Can we find ways to decrease or minimize the amount of sediment? Can we minimize the amount of nutrients? Can we decrease or minimize the amount of pathogens coming into the aquatic systems and bodies of water? So that's what we'll talk about in our next lecture, is, how does pollution get into groundwater? What's going on with the ocean? And then what are the different things that are being done to decrease that pollution? So lots of good stuff. So it's not all dark and gloomy and bad. There's lots of good things that is happening. We want to just continue that momentum and that positive movement of improving water quality for everybody.